Hello, today we are going to install Arch Linux, which is a Linux operating system, using the official installation guide, not using the archinstall command line executable. So first of all, Arch Linux, there's the wiki page. It started in the year 2002. It's always up to date because it's a rolling release model. Let's go to the website, official website. This part of the main web page is about latest news, which people that use Arch Linux should read from time to time. Then we're going to the download tab, and in here we are sent to the installation guide, and we are told that we can download the installation ISO file either directly using HTTPS from one of these mirrors, or maybe even better, and that's what's recommended, to use a BitTorrent download. This way, the ISO file that you download is guaranteed to not be tampered because it's checksummed automatically. Otherwise, if you download it from one of the mirrors, it's recommended that you actually check to make sure that the ISO file has not been tampered, and the installation guide says such a thing. Says that especially when downloading from an HTTP mirror, downloads are generally prone to be intercepted to serve malicious images. So at least this time I'm going to use BitTorrent to download the official ISO. So for that I'm going to use the BitTorrent client that I usually use, which is qBittorrent. It's already installed. Let's copy, I don't know, the magnet link. Start BitTorrent. No further e-notices will be issued. I agree. Open URL. It pastes automatically the URL that I have just copied from the web browser. Let's go download, downloads. Okay. Outpost. How do I see the details? Okay, so it's very well served. There's many peers that will serve this download file, and it's less than 1 GB in size. Okay. I will pause the download after a while or immediately, and let's move it to the correct directory. So that was downloads directory. I don't use this directory ever. Work to delete ISO, Control V. I'll delete the old ISO from October. Next up, I'll create a virtual machine. I'll use a virtual machine. I am using Virtual Machine Manager. Let's clean up something from here. Let's also delete this thing. Yes. New virtual machine. ISO. Browse. Arch Linux from 12, which is December 1st. This is the one. it automatically detects the name of the operating system, which will use a certain template to create a virtual machine. Let's make the virtual machine as beefy as possible. 10 gigabytes of RAM, 14 vCPUs, so 14 CPU threads. Let's make this at least 100 gigabyte. Arch Linux sounds okay. Customize before install. Finish. And usually the only thing that I need to change in here is the CPUs to not have 14 CPU sockets, but just one. Apply. Okay. Let's venture even more and not use BIOS. Let's use UEFI, which is, I'm not sure which of these. So this is secure boot. Let's go just like this. And let's review the settings of the virtual machine. So the newest motherboard, CPUs are correct, memory is okay. The hard disk is the fastest possible, which is vert.io. Correct ISO in the CD-ROM. And network interface card the fastest possible. So looks okay. Let's begin installation. Okay, so I didn't select correctly the UEFI, I guess. So let me recreate the virtual machine with the correct the correct firmware selected for the virtual machine. Okay, so I managed to get to boot the ISO. For that, I needed in the virtual machine to set UEFI, but not a plain one, but this version. The one with code and 4M and nothing else. So without MS and without secboot. So the name is something like ovmf underscore code underscore 4m.fd. Okay. So we are now paused in the bootloader. The ISO has booted. It's showing me this GNU grub, which is the bootloader. And I'm going to select the default option here by pressing enter. Says Control L plus Alt L to release the pointer, which means the left hand side control key and the left hand side Alt key pressed at the same time. So Control Alt on the left hand side of the keyboard. Okay, and now the Arch Linux ISO has finished booting. We're inside a live CD mode. In here, we might either start the Arch install, command line text user interface installer, which we do not want to do this time. I'm always using that, Arch install when possible, but this time, as an exercise, I'm going to use the default installation guide. So let's see how we can have these things side by side. Okay, so says require the ISO, acquire the ISO, which I did. I did not check the ISO, but then I downloaded over BitTorrent, and then there's chunking and hash summing and everything. So I guess the ISO has been downloaded correctly. it has also booted correctly, so that's also a good sign. I've booted in the live environment. I did not use secure boot. I did not need to enter UEFI BIOS to configure something there. Okay, I'm not using whatever. This is the shell. Vim nano MC edit. Okay. Set the console keyboard font and layout if you do not want English US. I do want English US, but if not, then these are the steps: locale ctl list minus key maps. Unfortunately, because we're in a virtual machine, we're not in a SSH connection or in an RDP connection. Probably copy paste does not work, so we'll have to manually dictate to yourself and enter all of the text yourself. Yep. For German, that's the command line load keys space d minus Latin 1. I do not want to change the console fonts. I'm not actually using the console. I'm using it just to install the application, the Arch Linux operating system, and then from then on, I'm going to connect to the machine only using OpenSSH or the RDP protocol. Verify the boot mode to verify if it's UEFI and the bitness. Let's do that. We went the hard way, which is UEFI instead of BIOS boot. Auto completion works. F tab FW. Okay, so it's 64-bit, which is 64-bit UEFI. Yes, that's what I have selected in Virtual Machine Manager. Okay, so we do not need BIOS CSM. We are not limited to systemd boot. Okay. Says that I need to connect to the internet. IPA. So there's one network interface card, which is ENP1S0, which seems to have correct Internet IPv4 settings. These INET 192.168.122.225. So the virtual machine offers a DHCP server, which it seems that the Arch Linux ISO has used. So it has started a DHCP client automatically, has configured the network interface card correctly. This means that we can ping, and ping works okay. Control C to exit ping. So the installation image has modem manager, systemd, network D, systemd, resolved, IWD, install configured, but only in the live CD mode. Okay, update the system clock. Let's see if the clock is accurate. Time date CTL. Let's resize a bit the virtual machine. So says time zone UTC 1434, which is correct. So it actually did use systemd time syncd. It actually did connect to a network time protocol server and set the time and date correctly. Next up, partition the disks. Okay, let's actually use lsblk. to identify the disks. So that's just one disk which we're interested in, the one with 200 gigabytes, the one that we have created for the virtual machine, which is s/dev/vda. Let's also see what fdisk-l does. So /dev/vda, 200 gigabytes, similar output. It says that if we have a device that's named ROM, which we do not have, loop, which we do have, airboot may be ignored. Okay. And then it says that we should create partitions on the VDA, virtual hard disk, at least one for the root directory for slash. In our case, we're booting in UEFI mode, so we need a EFI system partition. And then space for swap could either be a partition or a file. Let's go with a file. So we need to create two partitions, one for slash and the other one for EFI. Okay. Says that the EFI partition must be at least 300 megabytes. If we'll have multiple kernels, should be no less than 1 gigabyte, so we'll assign, I don't know, 4 gigabytes for this thing. Let's start the nodes. So we need what is this? A EFI partition, which should be 2 gigabytes, and then slash, which is the remainder. Okay, so we're using UEFI with the GPT. Okay, let's start doing and then we'll see. How do we partition the thing? We're using a partitioning tool like fdisk. So let's go there. Fdisk and then the disk to be partitioned. So fdisk, we're at this line. And then the device is dev/vda. Okay. Says that it has created a DOS MBR disk label, which we do not want. We want a GPT partition table. So let's go M for help. And says, where do we create a GPT? Letter G, create a new empty GPT partition table. Okay. Let's actually write and exit, W, and go back. So restart fdisk /dev/vda, just to make sure that the when we first started, fdisk /dev/vda was totally empty, but then fdisk wanted to create an MBR partition table. We've told fdisk to not use an MBR partition table, but use a GPT GUID partition table instead. And let's see if it actually did do that. Okay, how do we list? M for help. Previously it said MBR in here, and now it says GPT. print the partition table like this. Yes, so I've used the lowercase p, says disk label type GPT, and there's 0 partitions in here. We'll start up with the EFI partition. We'll want to create that. So how do we create a partition? N for new. Partition number. We do not know what partition number to use. The partition number, yes, it's the first. So GPT can have up to 128 partitions. We'll use just 2. The first one is default one is going to be the EFI partition, so I'm going to press enter. The first sector is 2048, which probably the first sectors are going to be used by the protective hybrid MBR. So we do not want to go before 2048 sector. So the first sector is okay, press enter. And then we want to assign it a size, which again should be at least 1 gigabyte. And we selected, let's go with 4. Uppercase G, that's 4 gigabytes. Value out of range. Let's go with plus 4G. Okay, so it has created a new partition of type Linux file system. Let's set the partition table, the partition type for the first partition, which is T. Change the partition type, this one. But for that, we need to know the list of partition types. So that's L. EFI system is probably this one with 1 with this GUID. Q to exit. M for help. I want to change the type of the first partition, which is this T, change a partition type, so T. Then the partition that's selected is the first partition, which is okay. And then partition type, I remember it's the partition type 1. EFI system, right? Next, I want to create the last partition, the second partition, / with everything else. First sector is okay. Last sector is the last possible, which is okay. 196 gigabytes, type Linux file system. Let's see if this type is okay. For that, we're going to list all known partition types, which is lowercase l. And the only possibility is Linux file system 20. And that's what's already configured. So Q to exit, M, and then we're going to print the current settings, the current partition table with lowercase p, and do a recap. Disk label type GPT correct, VDA1 EFI system 4 gigabytes, VDA2 the rest 196 gigabytes Linux file system. So it looks okay. We've created the partition table, we've created 2 partitions, but then the partitions do not do anything, they're not even formatted. So it's time for us to write and exit, which is W. Okay. lsblk now shows under /dev/VDA2 these partitions, VDA1 and 2. Okay, so we're at this layout, but without a swap partition. Let's see what it says next. It says if I have an ext4 partition, which I want to create, let's format that. So mkfs.ext4. I want /dev/VDA and 2. Okay. Journaling, ext4, the default Linux file system works great for me. That's what I always use. I do not have a swap partition, so no need to make swap. And then it says if I have created an EFI system partition, I did that. Format it to FAT32 using makefs.fat. So let's see the command line, which is this one. Makefs.fat minus uppercase F32 and then /dev/VDA1. So this one, VDA1, which is 4 gigabytes in size. Done. Now we'll need to mount the file systems and then we'll chroot into them. So let's make sure we have a /mnt directory. -L. So it's empty, owned by root, and exists. Okay. Now we're at this command line. So mount what, which is a device that already exists, VDA2, we can see it in here, the large one, and /mnt. Okay. So the mount table now says that /dev/VDA2 is mounted on /mnt with the correct file system, which is ext4. Okay. We'll need another mounting point for UEFI systems. So we're on a UEFI system. We need to mount the EFI system partition as /mnt/boot, which directory might not exist. That's why we're using the parameter --make_dir. So ls-l/mnt/boot, just mnt. So mnt is empty. There's no /mnt/boot directory. So mount -make_dir /dev/VDA1. Hopefully that's what we have. Yes. And then /mnt/boot. Again, mount -make_dir /dev/VDA mnt boot. Go. Okay. Let's run mount again. So VDA2, the bigger one, is on /mnt, and the smaller one /VDA1 mounted on /mnt/boot. Looks okay. We will later use genfstab to create /mnt/etc/fstab. I need to select the mirrors. On the live system, Reflector updates the mirror list by choosing 20 most recently synchronized HTTPS. Let's look at the list. So it says that we have VI, Nano, and MC edit, which probably means we have MC here, which we do. So I know, let's use Nano /etc pacman.directory and then mirror list. Let's see what's there. Some random things. edit the file accordingly, move the geographically closest mirrors. Why? Because often the geographically closest mirrors are not 1 gigabyte in transfer speed. Their upload speed. Okay, install the essential packages. So let's exit. On the bottom left, we can see that the shortcut is this caret, whatever character, which means control and then X. So control X to exit, control L to clean. And now we're at this command line. So let's copy it very correctly. Backstrap -k /mnt base Linux firmware. So what will this thing do? Inside of /mnt will prepare all that is needed such that we can chroot into /mnt, so similar to the bootstrap. We'll install a ton of binary packages from Arch Linux, including the base package with all of its dependencies, Linux, which is the Linux kernel, and then Linux firmware. I'm not using a container. I could not use Linux firmware probably because I'm using a very standard QEMU virtual machine. So after this command, I can add any other commands, any other names of Arch packages as needed. Okay, so let's actually do that. Let's add some commands, some Linux packages that I commonly use for surviving in the command line in the terminal. So that would be Midnight Commander, emacs -no x, git, and that's it. Let's look at the download speeds. 34 megabytes, not megabits per second, so that's more than 100 megabit per second, which is really good. So 141 Arch Linux binary packages to download and install. All of them have been downloaded. Now they're being installed. Cryptography, TIFF, image, libraries, Git, put images, init cp.io, the init RAM disks, Linux firmware, and it should be done. So I should consider installing user space utilities for file systems. I'm not using any special file system, just ext4, which is already formatted. No additional firmware. Hopefully we have a DHCP client and network manager. Text editor I did, emacs no x. So hopefully it installs software necessary for networking. Or not. Consider installing. I know, we'll see as an experiment. Do we have networking inside of the chroot after installing just these 3 Arch Linux packages and then chrooting inside or not. Okay. So this is the chroot command line. Before that, we're going to need to generate /mnt/etc/fstab. So let's do that now. Gen-fstab -u to use labels, UUIDs, /mnt, and this is the redirect standard output by appending to a file /mnt etc fstab. So gen fstab space -u uppercase u space /mnt greater than /mnt etc fstab. Great. Let's look at the file, see if it's okay. Nano /mnt /etc fstab. Hopefully it's okay. Ctrl X to exit. And now, drum roll, we're going to change the root into /mnt. Arch chroot /mnt. Okay. Bing archlinux.org. It still works, the networking, that's great. So inside the /mnt directory right now, we're still using the Linux kernel that's from the live ISO, but all of the rest of the file system is used straight from /mnt from now on. So it's exactly as if we would have booted inside of the virtual hard disk, not from the live CD. And usually this is the way you actually do recovery on your Arch Linux installation. You boot from the official Arch Linux ISO, and then you chroot into /mnt, and then you do your reinstall packages, edit files, etc. in there. Okay, so set the time zone. Let's see if we keep having MC in here. We do. It's great. So we'll need to find a file in /usr/share/zoneinfo/region/city. So let's look in there. So ls/usr/share/zoneinfo. We're in America. And in here, we have New York. We do, but it's spelled like this. So let's run this command line. ln, which means create hard link or symlink, -n, which means symlink, f, I'm not sure what, force or file, and then the hard, which is the existing file. So region was America, and city was New York, /etc/local time. Okay, so lnsf, correct file name because I auto-completed, /etc/local time. Okay, and then generate /etc/adg time. So hw clock --sys doesn't have auto completion to hc. So hardware clock system to hardware clock. So copy is probably the correctly set date and time by using NTP network time protocol to the hardware clock, which is the BIOS clock. Okay, assumes that the hardware clock is in UTC, which it is because we're on Linux. Should set up time synchronization using systemd time syncd. Yes, how do we do that? Localization. Okay, exactly this locale we do need. So we can edit /etc/locale.gen. How do we use the editor? We could use nano /etc/locale.gen. Says we do not have nano because we did not install it, so we could install it. -s nano. So we're actually inside the normal Arch system, the one from the hard disk. The only thing that comes from the live CD mode is the Linux kernel, the kernel mode. The entire user mode is from the hard disk. So that's why we can install packages using pacman-s will install on the hard disk. Proceed with installation. I did not actually need nano because my preferred command line text editor is Emacs. So I can also use Emacs if I want. So etc locale dot gen. Yes. So it says edit /etc/locale.gen. It's sorted probably alphabetically, so we'll need to go to the letter N, so E, so page down, EN, and probably the first one there, hopefully, not really. So it's sorted alphabetically. EN, US, UTF-8, UTF-8. So save, Emacs, that's Control X, Control S, and exit Control X, Control C, Control L to clean. Now we need to have this file created for us, which does not exist yet, using this executable. So locale -gen. Let's look at the content of this generated file. Let's see locale.conf. There is no such file. We need to create it. Okay. So we can create it by editing it. Let's see /locale.conf. So nano space /etc/locale.conf. Should have this complicated content, lang equals en us.utf-8. So lang all uppercase equals en_us.utf-8. I put a trailing new line, so an empty line. Control X to exit. Asks if I want to save. I go Y to yes to save. And then the correct file name is selected. I press enter. Control L to clean. I do not want to set other console keyboard layout or font or anything else. I want a host name. So nano /etc host name. There's no such file. The host name is Arch Linux. Okay, Control X to exit, save modified buffer, lowercase y, and then enter, Control L. Okay, so we want to configure the networking. What networking stack should we use inside Arch Linux? Ensure your network interface is listed and enabled. That's IPA. So it's enabled, it's up, we can ping. Control C to exit. Connect to the network. I have the Ethernet cable because it's a virtual machine. I have the network configured. The network uses the DHCP. Okay, what else? Routing table, automatic. Where's the network configuration? Okay, so for now, the networking works correctly, but that's because I'm still using some remnants of settings from the live CD. Once I reboot, I finish installing Arch Linux on the hard disk and reboot, I might not have networking inside. For that, I'll need to install an entire networking software management stack, which in my case should be probably Network Manager. Network Manager lets you manage network connection, settings, profiles. Okay. But how do I install? How do I set up this thing, Network Manager? I do not want to change interface names. No MTU, no settings. I did set the host name. Miscuous mode. Okay, probably this wiki page. Network Manager can be installed with a package. Network Manager contains a daemon, command line interface, and MCLI, curses-based interface, and Network Manager, TUI, text user interface. After installation, I should start enable Network Manager, so it might not even be enabled. Okay, so let's do that. Pacman minus uppercase S. The name is Network Manager, all lowercase. BlueZ for Bluetooth. Lib Network Manager. Mobile. SSL. Wi-Fi. Okay, let's do that. PPP. Looks okay. So next up, let's see if the Network Manager service is enabled by default. So that's systemctl status network manager dot service in chroot status. Control left does not work. To jump one word to the left. So enable. Probably we cannot use minus minus now. So create symlinks. Great. It will automatically connect to any available system connections that have already been configured. Any user connections or unconfigured connections will need an MCLI. Sounds okay. No modem manager, no PPP, no VPN. Okay. Hopefully we finished this chapter, which says complete the network configuration of the newly installed environment, may include installing suitable network manager software, configuring it necessary, and enabling its systemd units so it starts at boot. We did that, right? Next up, we'll need to create a init ramfs. Without that, maybe the kernel cannot boot. So let's do that. We don't use LVM, we don't use encryption, RAID, or anything else. May not be required because make init CPO was run on installation of the kernel with packstrap, but we're doing it anyway just. So make init CPO minus uppercase P. Okay, so now we have a Linux kernel, we have firmware, we have init CPO. We do not have a root password, so let's do that. We should not use the root password. We should create an actual user that has the power to use sudo, but still. Okay. And the computer will not boot because we do not yet have a bootloader. So choose one of the bootloaders possible. And then you can reboot. So let's look at the bootloaders. A bootloader is a piece of software started by UEFI, loads the kernel, knows the kernel parameters, knows the init ramfs, knows some file systems, etc. Adjustments in the bootloader for microcode, let's ignore that thing. All UEFI bootloaders support GPT disks. Okay, that sounds okay. And now I need to select one of the possible bootloaders. I've always ever just used grub, nothing else. In the year 2000, previous to grub, there was Lilo. Okay, so let's go to the page for grub. Let's see how it does. So it knows FAT32, ext, great. We have a /boot, which is FAT32, UEFI systems. Okay, what's this? Okay, so it looks like we have these requirements. We did boot in UEFI mode. Okay, installation. We're not booting 32-bit. First install the packages grub and AFI boot manager. FE boot mgr. So EFI boot mgr. Writes boot entries to NVRAM, non-volatile read-only access memory. Random access memory. Non-volatile random access memory. Mount the EFI system partition and in the remainder of this section substitute ESP with a mount point. That. It's already mounted. The partition with GPT partition table type EFI system partition is mounted as /boot. So that's ESP. I have chosen the bootloader, which is grub. Do we have any steps? Execute the following command. A directory of the name will be created in /esp/efi. Probably I do not need to create it. It will be created by this long command line. Yes. And this is the name that will appear in the UEFI boot menu to identify grub boot entry. Execute the following command to install grub EFI application into /boot/efi/grub and install its modules to /boot/grub. Make sure to install the packages. I'm not sure what that thing's about, but sounds okay to me. So grub install --target x86_64 -EFI -EFI -directory equals ESP -bootloader -ID equal grub. Okay, so let's read again. Grub install --target equals x86_64 -EFI -EFI -directory equals ESP. Not ESP, because ESP is this italic thing. So that should be /boot. Okay, so this is a command line. We can see it's uses monospaced font, but then this is italic monospaced font, which means we should respect what it says in here, which means ESP is the mount point of the EFI system partition, which we've looked with the mount command line. We know it's /boot. Okay. /boot/grub. It looks okay to me. Let's go enter. Okay, let's go mc/boot. it said that a /boot/EFI directory is going to be created. Let's see if it did that. It did. Inside there will be a directory named grob, which is the contains the EFI binary. Then in /boot/grob/x86 will be the grob modules, which it did. And because it's /boot in here, we have all of the kernels and init RAMs. We'll need to make sure we don't install too many using pacman, because this /boot partition is only, I don't know, 4 gigabytes in size. Okay. It looks okay. Probably that's all to it. We've installed grob successfully. No secure boot. Not sure what this thing is. GPT partition, table specific instructions. After installation, what is this? Generated grob.cfg. Just a second. Okay, so it says that we have installed grob in EFI mode, but then although grob has the Linux kernel, the init/ramfs, it still requires a configuration file. So grob will search for /boot/grob/grob.cfg, a file which does not exist yet. And that needs to be generated. Okay. Says that we should look at /etc/default/grob, which we can do. Tab F3. I'm not sure what to look in here. It all seems okay. It's just general settings, and then the 3 important settings in here, which is timeout until it boots the first entry or the last selected entry in the boot menu, which is probably 5 seconds, this line. And then the 2 command lines for the Linux kernel, which is the default one and the other one. It says log level 3 and quiet. So these seem to be defaults that are okay. But then again, this file is missing. /boot/grob/grob.cfg. We need to generate it. There's also /etc/grob.d. If you are trying to run grob make config in a chroot, you might notice this error. I'm inside arch chroot, which is okay. Okay, so I do not know anything better. I guess I should run this command line. So grob minus make config minus o /boot grob.cfg. So grob minus make config minus o for probably for output file /boot/grob/grob.cfg. it found only one boot possibility, which is one Linux kernel. And there's also a fallback initram file system. Okay, OS prober is not being run because that was commented out in the config file, which means if I have a Windows operating system here, probably will not be detected. It's not a case, it's just a virtual machine, Arch Linux only. Okay, I'm not detecting other operating systems, no Windows, no additional arguments, because I'm not using a swap partition yet. I'll be back once I enable the swap partition. No LVM, no RAID, no encrypted /boot, no LUKS2. Okay, so we need to be back here when we configure the swap partition for Hibernate, but it's a virtual machine, will not hibernate. Okay, back to where we were. Says install a bootloader. I think I finished installing the bootloader grab correctly. Reboot, so exit the chroot by pressing Ctrl D or exit. Let's go exit. Optionally manually unmount all of the partitions. Mount -r/mnt. Okay. Restart the machine. When did it copy the list of mirrors? The file will later be copied by backstrap, which we did execute. Okay, so we should have pacman -s work correctly. So reboot. We're not going to reboot, we're going to shut down, because it's a virtual machine. And shut down again. Okay, and let's look at the settings. In SATA, CD-ROM should be nothing, which is the case. And then boot options should have just VirtIO. Okay, now we can start the virtual machine. Here we see grub. There's the default entry, 5 seconds timeout, VDA2, it boots. We're at the login prompt on TTA1, so the virtual terminal 1. We have no users available, just the user root. Okay. So post installation, first of all, we need to make sure that networking works, IPA, configure correctly. Ping works correctly. The minimum morum thing that we need to do here is to create another Linux user and make that user be able to use sudo. Okay, so let's do users and groups. We have the user root, user groups, user management. Okay, so we need to create another user. With this command line. Okay, so let's go that we'll need the login shells. So let's see if we have bash. We do. In the live CD there was Z shell and no Z shell. I'm using bash, so that's okay. User add -m minus additional groups. So for additional groups, which are the additional groups that we want? Let's search in here for wheel. So that would be arch wiki sudo. Let's see. The user that we're adding right now should be member of the Linux user group wheel, but do we not need other our user to be member of other user groups? Okay, at least not here. So back to the command line where we added the user. That. This line. So at least wheel that I know of, the a user Linux user group will be created with the exact same name as the Linux user name. No need for a login shell. Hopefully it's bash by default. Okay, so we don't need to go -s and then login shell because bash will be default. And then the username. So additional groups is probably comma separated. Okay, administrator, group wheel, user add, go. Okay, let's check that the user administrator works correctly. Exit. We're back at the TTY1. Let's log in as administrator. Administrator does not have a password yet. Okay. So we need to set a password for the user administrator. Password administrator. Okay, Control D to exit. Administrator. Yay! So administrator for now cannot use sudo because sudo is not installed. So we'll need to use plain su, which probably is available always, I guess. Asks for the password not of the user administrator but of the user root. Okay, and now we'll need to have sudo available. So how do we do that? We could use do as, we already have installed su, or we could use sudo. Okay, so do as is available by default in OpenBSD and in Alpine Linux, but most of the tutorials online will use sudo. So let's go there. So I'm the super user. Minus s, let's install the updates. Licenses, okay. And then let's install sudo. And then we'll need to configure sudo, because by default it doesn't allow users of the which are members of the Linux user group wheel to use sudo. For that we use this command line vsudo, but this is the way it's recommended to use vsudo, such that the editor is nano, not vi. Let's endure the vi editor. Says that we did not install vi yet. Okay, so editor could be nano and then vsudo for visuals editing of the sudo configuration file. Okay, in here we'll go to the bottom of the file where it says something about the user group wheel, which is one of these two. This is the riskier one, where all of the users which are member of the Linux user group wheel can use sudo, but then a password will not be required. Whereas this is the default on most Linux operating systems, where users which are member of the Linux user group wheel can use sudo, but the password of that user will be required. So not the password of the user root, but the password of that user. Control X to exit, Y to save, press enter. And now back to where we started. So we're the user administrator. Let's use sudo and then su. Ask for the password of the user administrator, and sudo works correctly for the user administrator. Okay, what's next? Okay, so post-installation general recommendations. I did the users, I'll need SSH, so let's do that. We're going to use OpenSSH server. Install the package OpenSSH. So I'm the root user right now. Pacman minus uppercase S OpenSSH. It's installed. Let's see if it's enabled and running. So system ctl status set SSH OpenSSH. I'm not sure what the name of this thing is. SSHD, or the SSH daemon. Okay, it's loaded, so it's inactive because it's stopped, but also preset disabled, so we'll need to enable it. That's Control F does not work yet. Systemctl enable -- now and then SSHD. Okay, that should be everything needed for starting and installing SSH. we'll just reboot the machine and hope for the better. And then if we can connect over SSH, we do not need to use this application anymore, which is the Virtual Machine Manager console graphical console spice. Okay, so reboot. Let's find out the IPv4 address. It's with 226. Control V. It finished booting. Let's connect to the virtual machine using SSH. So SSH, username, IP address says that the virtual machine manager virtualization software has previously used the IP address v4 ending in 226 or something, and that I should run this command line. Okay. Now I'll be able to connect. Do I really want to connect? Yes. What's the password? Can it do sudo? Yes, it can. Now that SSH works, I have installed all of the software needed such that if I reboot the machine, everything works, grub works, the Arch Linux boots correctly, the user space works correctly, I can connect using the SSH server, networking works correctly, I can ping Pacman, the package manager works correctly. Next up, I should install a graphical user interface desktop environment, which the one that I use is called KD Plasma. Let's go there. So we're using Pacman. For now, we've run just two possible command lines for Pacman, which is the one to install packages, which is this one, and then the one to update the metadata of packages. So how Pacman works, there are on the Arch provided by the Arch Linux distributions some web servers where there are repositories of Arch Linux binary packages. So both the Arch Linux binary package and a file that contains metadata about the packages. So it says in this repository there's this list of binary packages available. These are the names, these are the versions, so that's metadata about packages available in package repositories. So everything is configured correctly, including the mirror list. This allows us to install any of the Arch Linux binary packages that are available in those repositories in order to make sure that the metadata about available packages is downloaded locally available for pacman-s to search through. We're using this command line. Uppercase S, lowercase y, and then U. And then this also, so this first step is synchronizing package databases, which means it downloads the package metadata from the repository to the local computer. And then it also did a full upgrade, which means looks at all of the local packages that are installed, asks if any of these packages have a newer version. If so, it downloads the newer version of the Arch Linux binary package and installs it. Nothing to do right now. Okay, Pacman has a man page. Nope. Then it has a short help. It was in the Arch Linux, it said that you could install documentation and man pages. Not sure where. Okay, so we might want to install man pages and info pages. So we might want to run this command line. Pacman minus uppercase S, Ctrl Shift V, and now we have copy paste working because we're connected using SSH, which is a vast improvement compared to using this thing where we copy paste did not work. Okay, so let's try this. Manual database, manual pages, and text info. Says that there are no manual pages installed on my computer, but they're available in the Arch Linux repositories, which I want to install, yes. Let's see if Pacman has a man page now, and it does. Okay, so you can query packages, both installed packages and available packages. You can search through the installed packages or the packages that can be installed. You can update the package metadata. You can upgrade all of the installed packages. You can install new packages. You can uninstall packages. So -R to remove, -S to install packages. Okay. Next up, we have repositories and mirrors. You will need to look at the mirrors that Pacman is using. If you notice that the download speed is too slow for your tastes. Okay, we're not using ports, Arch build system. We'll probably use Arch user repository, AUR. And now we're up at the graphical user interface. We're going to use Xorg. We're going to use a desktop environment, which is KDE, and a display manager, which is SDDM. How do we do that? How do we install KDE Plasma? I know, probably we need to install Xorg first and then KDE Plasma second. So let's do that. So Xorg can be installed by installing this package. Pacman minus uppercase S, Ctrl Shift V. Okay. So it installs XCB protocols, lib input, some fonts. Okay, X libraries. Looks okay. What else? Says Xorg apps. Maybe we want an Xterm. So let's do that. The most minimal graphical user interface command line terminal. Okay. We're not using OpenGL. We're in a virtual machine. Install the appropriate driver. I'm not sure if we need such a thing. Didn't we install anything at the previous step? Doesn't look like. So it should be XF86 video something. Okay. So we'll ignore this step for a while. I'm not sure exactly what to select in here. We'll probably need all of the Noto fonts possible. So let's try that. Arch, package, search, Noto. Okay, so this is the list of available Noto fonts. It will also use CJK, emoji, and extra, but these are optional dependencies. So we probably want these. Noto minus fonts. How do we install these? Middle click to paste from selection. Okay, what other possibilities do we have? Not sure what nerd is. Emoji we did. What is fonts main? Package search. Okay, CJK emoji extra, and that's it. Okay, so this looks okay. Back to installing the KD Plasma desktop. So we have the Plasma group or the Plasma meta package. There's a minimal installation which is called Plasma Desktop, which I'm going to go with. Okay, so let's see. Alt backspace works to delete an entire word. Control Shift V. Let's see. There are two providers available for jack. Which I want is Pipewire. There are two providers available for Phonon Qt 5. Which I want is, I don't know, probably VLC. Proceed with installing a million packages, but then does it install a X server or not? Doesn't seem so. There's no XF86 in here. For a more minimal Plasma installation, there's the Plasma desktop. How minimal are we talking about? Dependencies 28, where are they? Okay, so we'll try to install the KD Plasma desktop, and then we'll set up XRDP, the remote desktop protocol, and XRDP. But first we should start in the virtual machine, the desktop, to make sure that we have enough things there. So did this thing install SDDM? The preferred display manager is SDDM. So let's install that. SDDM, and then maybe also this package SDDM KCM. Okay, still did not say anything about an X server. We'll reboot, and if it fails to boot in graphical user interface mode and start SDDM, then we'll see. So in the virtual machine manager, it starts in text user interface mode. This is probably because we did not yet install Xorg correctly, which I do not know how to do. I'm not using Intel, Nvidia, or AMD because it's a virtual machine. Okay, probably we'll need to install the VESA one. Let's see. So let's connect using the SSH. Become super user. Let's run this thing. Let's run this thing. QXL. What is that? So the recommended one might be VESA, this guy. QXL. Certainly not the ones that are specific for certain hardware, such as Nouveau, OpenChrome, SYS, Voodoo, ATI, AMD. Let's see this one. It still boots in text user interface mode. I'm not using configuration files. Okay, so after we've installed SDDM, which is the desktop manager, it says that at chapter 1, follow the display manager loading the display manager to start SDDM at boot. So let's go there. To enable graphical login, enable the appropriate systemd service. So it's sddm.service. Okay, so let's do that. Enable the appropriate systemd service. So as the user root. Sit vt0 vt2. Okay, and now we can log into, hopefully, into KDE Plasma from the desktop manager. So the desktop manager is this screen that allows you to choose the user and type of session. Okay, so KDE Plasma has started correctly. Okay, what does it have installed by default? So again, we installed that minimal KDE Plasma binary package. So it has the Qt framework, no web browser, VLC because that's a backend of the multimedia framework in KDE. That's the one I have selected. And then, fortunately, we've installed Xterm as an Xterminal when we've installed the Xorg server, because we don't even have Kate available. Also, fortunately, we can connect using SSH, such that we can install additional packages that are needed in order for me to survive there at the graphical user interface. So I want at least the following packages. So I want a text editor kit. I want a console, a terminal. I want Firefox, a web browser. Let's see if this is enough for now. Okay, they should be available immediately in the start menu. So there's Firefox, there's console, and the text editor kit. Okay, I'll favorite them. So Firefox should be pinned in the KDE Plasma panel, which it is. Let's unpin this thing. And then I'll also pin to the start menu, so add to favorites the terminal and the text editor. So now favorites should have Kate and console. Console works, Kate works. Okay. After KD Plasma works correctly in the virtual machine using Virtual Machine Manager Graphical Console Spice, I'm going to log out as the user and continue installing the Remote Desktop Protocol server. So this is Microsoft's Remote Desktop Protocol. This is what I'm using. I have my notes on how to install the RDP server on Arch on the family of Linux operating systems based on Arch. Okay. So let's see how we do that. So Arch Linux XRDP says that I should install from AUR the package XRDP and the package xorg XRDP, but then what is AUR? How do we install packages from AUR? Installing packages. Acquire the files, verify, run, make, and then a binary Arch Linux package will be generated locally, which you can install. They depend on basediffvel, which needs to be installed. So let's install that. pacman minus uppercase s base minus devel. Yes. We've already installed Git. And then it says that we should do this thing, but not as the user root, because the command lines are prepended with a $sign. So command lines that have a $sign at the start means that you must not be the user root. So let's get out of there. Who am I? Administrator. Where am I? PWD. Correct. So let's create a directory work and change there. Then we need to git clone this thing. And the name of the package, which is XRDP. It says in here the Git repository. Alt backspace, Control Shift V. Okay, it has a ton of dependencies. Hopefully it knows how to install them. Okay. Then I do not want to download a snapshot nor a branch. I want to build. Okay, so let's do that. So cd, the name of the directory is xrdp. It looks like this. In here, I should look at the package build, which I cannot really view. So name version depends on lib, xrandr, fuse, these things. Let's get out. Control G, Control X, C. Says make the package. Using this command. And -s will sync depths, automatically resolves and installs any dependencies with pacman before building. If the package depends on other AUR packages, you will need to manually install them first. It does not depend on any AUR packages, but does depend on Arch Linux packages that are available for installation via pacman -s. Okay, let's go with -i to just install. It needs to install two Arch Linux packages, yes. Two more. So it has downloaded a source code tarball release of the package XRDP. It has uncompressed it. Then it's running GNU configure. Then it's running probably GNU make. Let's actually look if it's configured correctly. So MP3, Fuse. What doesn't it have? Everything is configured correctly. Great. I'm not sure with how many CPU threads it compiles. Does it have -J14 in the command line? Okay. After that, it runs check, so some tests, which are successful. Okay, tests some more. Makes a package, a binary Arch Linux package. Which is in the current directory. And then it asks me if I want to run pacman -u this package to actually install it. So the name of the package is in the current directory, xrdp, this version, and then pkg dot some extension. Proceed with installation, yes. So that was for the AUR package xrdp. Now we need to do the same thing for another AUR package, which is xorg xrdp. So let's look at the command lines. We need to go back up one directory to be inside of the directory tilde/work, where we're using git clone. So git clone, and the URL is the same, but with an xorg in here. So xorg xrdp.git. Okay, now we need to change into that directory. Then we need to run the command line that builds and installs. So make package space -s space -i. Do I want to install X libraries? Yes. So it did not, it could not verify one PGP signature. Okay. And we need to temporarily work around this thing. So it says that I should, I can, one of the two possibilities is either to import for my user account the GPG serve, which is the GPG key that's mentioned in the package build file, or I could tell make package to skip PGP check. So let's actually do that. This option. Okay. Okay, so let's while it's doing its things, proceed with installation, yes. Let's continue reading my wiki page. So it says that I should install these two AUR packages, Xorg and Xorg XRDP and Xorg XRDP, for instance, manually, as I did it now, per the Arch official instructions on how to build and install AUR packages, or I could have used a AUR helper such as YAY, which is, this is the way you install a YAY, and then it's easier to install the two AUR packages. Okay, but we're at this step. We finished installing both AUR packages, XRDP and Xorg XRDP. We'll need to enable the systemd unit, the service, and then two more steps, and we'll be able to connect from any other computer to the virtual machine using the remote desktop protocol. From Linux, I connect using the client X3RDP. From Windows, I connect either using the Windows built-in remote desktop protocol client or using sysinternal sudo RDC-man remote desktop connection manager. Okay, so let's look at this configuration file. It does not exist, so let's create it. How do we do that? In Nano. Should have this content. Control X, Y, enter. I'm not a super user. Control X, save modified buffer, no. So I need to become super user. Y, save. Okay, and then we're going to look at the content of the file again. So has the content that we wanted, allowed users anybody. Correct. And then in my home directory for the user administrator, there should be such a file. With this content. Let's put a trailing new line, Control X, and save and write. And reboot. Okay, once the computer finishes booting, we should have modified the grab 5 seconds timeout, make it 1 second, for instance, when we had the chance. And then we also need to set up a swap file because we do not have one. So let's do that before anything else. Okay, let's clean some files, some tabs. So we want arch wiki swap file. Let's see if we have swap. We should not. Nothing. We could use a partition. I do not want to do that. Or we could create a swap file, which is what I want. It creates a 8,000 megabytes, so that would be 8 gigabyte swap. That's okay. Let's do that. Let's make it even smaller than that. Let's make it 4 gigabytes. I'm not super user. I should be the user root because the command line starts with a hash, a pound sign. So that means that this command line, you should run it as root. So either become root or prepend the command line with sudo, with doas, with whatever method that you have to run a command line as the user root. Okay, where are you? Control, copy, paste, make this thing just 4 gigabytes is okay because it's a virtual machine and it already has 10 gigabytes of RAM. And we're not hibernating. Okay, so what it does, it takes from the device /dev/0, which contains just a 0, and puts into the file/swap file 8 gigabytes of zeros. Okay, it did, and now it says that it's really problematic if the swap file is readable by anyone else than the user root. So let's change the chmod on the file. So it's not readable, writable, or executable by group, by anybody else, just by the user which owns a file, which is the user root. Okay, we make sure that the swap file has file system type swap. And we're activating it. Now swap on will list it. Where is it? Swap on show. And also free will list it. But the settings will be lost when we restart the computer. So we need to make the settings permanent. We need to edit fs tab. At the very end, we're adding this line. Okay. So there's no UUID or label because it's a swap file and has UUID 0. So that's why we use /swap file, not a UUID. Control or Control X to save. Y, enter. And that's about it. I have never used ZSwap or ZRAM, so maybe that's something to look into. We've just restarted the computer, so we should be able to connect remotely using the remote desktop protocol. So for that, we're using this command line. Copy it and we'll edit it a bit to have 226 at the end. Okay, the user is administrator. The size is the size of my monitor, but then because dynamic resolution, the client RDP window will shrink a bit to allow for my host machine to display its plasma panel. And also for space for the title bar of the window. Okay, so in a new tab in console, Hopefully everything works out. Make sure you're not connected to the graphical user interface KDE Plasma using the virtual machine. We're not. And now we're connected using the remote desktop protocol. So again, you can connect locally, which I do in this case from the host machine to the virtual machine, but then you can connect from other computers in your local area network or computers or over the internet using a VPN or a similar technology that traverses your wireless router. Okay. So we have a web browser, we have Kate, we have console. From here on, you do what you usually do in KDE Plasma. So in my case, it's installing additional software such as Crusader, the twin pane Orthodox file manager, Meld, a diff viewer, the Git GUI tools, and then if I do development on this machine, the development tools. And Firefox, I configure it to my liking. So this should be it. We have installed in a virtual machine the latest version of the Arch Linux operating system using the recommended procedure of installing Arch Linux, which is following this installation guide, this wiki page on the Arch Linux wiki. After we follow the steps, we got a installation of Arch Linux, which needed a few more changes because it only had a user root. It did not have any graphical user interface. So we've created another user, which is called administrator, installed sudo and made sure that administrator can use sudo. We've installed SSH because you cannot really copy paste to the virtual machine. So by connecting using SSH from the host machine to the virtual machine, now we have copy paste working. Then we've installed the Xorg server. We've installed SDDM and configured it to start. This way we could confirm from the virtual machine that we can log into the KDE Plasma X11 session and everything works correctly. We've installed KDE Plasma. And then as a final step, we've installed the RDP Remote Desktop Protocol Server Xorg, XRDP, and XRDP following these instructions. And as bonus points, instead of using the AUR helper YAY, we follow the official instructions of how to install AUR packages from the Arch Linux wiki. And also we've used UEFI, not BIOS, in the virtual machine for additional points. So this is it. Thank you.